always write show all calculations. So you need to show all these operations here.
Okay.
When you are using the augmented matrix, I'm going to write it down. Let me write the augmented matrix down so that people can know exactly what you are talking about. I can't remember very well, but I can just send 1, 1, minus 2 and 1, then 2, 2, minus 4 and 2, then 3, 3, minus 6 and 3. This is the augmented matrix. So I said the operation I used in the previous matrix is row 2 minus 2 times row 1, and then I put the answer into row 2. Okay, so some of you do it the other way around. They write row 2, then they put the arrow facing like this, and they say row 2 minus 2 to right. I don't mind, that is the same thing. So it's just that in your notation, you're doing the operation on the right hand side, and then you are putting the bracket, or I mean the arrow, it goes to from the left to the right, and then you say you're putting the answer in row 2. So someone else can say, okay, I use this operation here, and then I put the answer in this one. So that is the same thing. So if you write this one or that one, it doesn't matter. So let me keep it as it is to say this is the same as this one, or this one. And then at the same time, we did row number 3 minus 3 times, row number 3 minus 3 times row number 1, and then we put the answer into row number 3. So if you do not show this one, you're going to lose 1 mark for notation. So you see, generally I usually write minus 1 like this, and I write notation. So that means if I'm the one marking, yes, you're going to lose that mark for notations because you did not say exactly what you did. So you look at what's going to happen in the next row. What you're supposed to be getting is 1, 1, minus 2, and then 1, then you get 0, 0, 0, 0. So that was what we're supposed to get. So our new row number 2 is 0, 0, and then the same our new row number 3. So then at least I know that that's the operation that you did from that first matrix to get to the second one. So this information here and that one is basically the same thing. If you do like this one, someone else can do the reverse option and still get the same thing. I can just say I take row number 2 plus 2 times row number 1, and then I put it in row number 1. So I can say row number 2 plus 2 times row number 1, and then I put it in row number 2. Then I get that previous information back. I do the same row number 3 plus 3 times row number 3, I put in row number 3. So despite that it's 0, row number 2 and 3 are 0, 0. When I do the reverse operation, you see, instead of doing minus 2 and minus 3, to get back to the original matrix, I do just the negative of that. So minus of minus 2 become a plus 2, and minus of minus 3 become a plus 3. So that takes me back to the original one. So that's why the two matrices are equivalent in terms of outcome and information. Great. So okay, let's reason in this one in terms of the system. Okay, let me go back. I think there's some still hands up. I think Webi, I hope this answers your questions. Yes, please, you need to write them down. You don't write them down in terms of notation, you lose marks. So okay, Maseko, you next. So you must welcome. Yes, Maseko.
Good afternoon, sir. Can you please go back to your previous screen? I have 2 questions that I want to ask.
Yes, this one.
Can you please go up?
Here.
Some more.
Okay. Yes, here.
Yeah, that's fine, sir.
Yes.
So I wanted to ask that we use the first row to solve for the diagonal and the 3-0 triangle because the first row didn't change.
Yes.
So in essence, if we change the first row, then we couldn't use the first row to solve the diagonal.
Exactly.
Okay.
Exactly. Yes.
Okay. And
so you couldn't use the first row because you see that's where the guy before he was just a bit going ahead of himself, because you see what we're doing basically. We kept the first row as it is. What does that mean? It's like you're trying to kick a soccer ball. You need to have a pivot, or you're trying to go in rugby. You have, one of the leg has to be down on the ground so that at least you can use it to turn around or something like that. Something like a pivot, like an axe where you should be able to turn around it. So our row number 1, and that's why it's called Gauss. Why Gauss come into play is that he kept the first element, this one element here, as a pivot. This is where I'm going to work my pivot. I keep it as it is. To keep this element, you have to keep the entire element of this row. So that means that for you to get that pivot, you have to have. So then you only work around this diagonal, the remaining ones here, and then you work around the triangular one to make them 0. While you keep the one in the middle to make them 1, 1, 1. That was the whole Gauss technique. So you keep the first one as your pivot. Pivot means something that way you keep turning around it, and then you only maneuver on the remaining ones. So that's the whole purpose of it. Thank you so much for bringing that.
Okay.
So if you change that pivot, then you don't have a pivot anymore.
Okay, I see, sir. Then may I ask a second question?
Yes, go ahead.
For example, okay, I see that row 2, we have all zeros there.
Yes.
Then let's say that our right-hand side answer was also 0. So now my question, okay, since in that scenario we know that it's going to be infinitely many solutions, does that mean that as long as we know that there's a row with all zeros, we don't have to solve the other row? We automatically know that there's infinitely many solutions?
Yeah, that's what we are trying to introduce.
Okay.
So you see, we already know that the system here at the start, we solve it and say that it has infinitely many solutions. For each time you give a t value and the s value, in fact, even if you give t and s the same value, I didn't say t and s cannot be the same, then x will always be different, because t and z can be 0, x will be 1. T and z can be 1, 1, 1, then x will be 0, and then so on and so on and so forth. So it means that each time you change that, you get infinitely many solutions. Now the question is that, because you are ahead of us, so for us that we are still coming to linear algebra, we want to understand that notion.
Okay.
If the right hand side is 0, that's where we are going now.
Okay.
You can see here that the right hand side is 0. We want to relate this to infinitely many solutions. That's the whole purpose behind it.
Okay, no problem. Thank you very much, sir. I understand. Thank you.
All right, thank you so much. Yes, Sindani, Specifically, you are back. You are next, sorry.
Yes, sir.
Yes.
So I wanted to ask if maybe we have a matrix and then an augmented matrix, and then we do the cross elimination or the forward elimination where we make everything under the ones or the pivot position 0, and then we get another matrix which is reduced or it's a row form. We can get different types of those. Someone may get the different matrix from me, but yes. So I wanted to ask, how do you confirm that you are right, or is there a way to confirm?
Yes, but how do you confirm that you are right? At the end, once you finish solving, you are going ahead, because here we pick just a specific example for infinitely many solution that we're trying to show using a matrix. When will we say infinitely many solution? So that's not the only example. We're still going ahead. So which means that there are so many other systems that we're going to solve, and then once we solve those systems, we get there are cases where you don't have infinitely many solution, like this one. We get it different, like the one you're talking about. And then let's say if you get infinitely many solution, there's nothing to confirm. So you can just double check that it's really infinitely many solution by checking that the two systems the two planes are parallel to each other. The second or the third or something that gives you. So let's say we only got 0, 0, 0 at the end, but the middle zeros, they were not 0. So it means it's still going to take us to infinitely many solution. That's going to be a different example I'm still going to bring. So I'm starting with the one with double zeros. Then I'm going to reduce it to another one with there's no double zeros, but only last 0 at the bottom. Then we get the cases of infinitely many solutions covered, done and dusted. Then we move to the next one. What is it? There's infinitely many solution. What did I say about in the previous discussion? Another case is you have one solution and only one solution. We take a different type of examples where you have one solution and only one solution. And then how do you also check it, and what is the objective? Then once you get that one and you reduce the matrix as you mentioned, yes, after you get the solution, because it's one and only one, or unique in a sense, then you can test it. How do you test it? You take it and substitute it back into the original matrix, or you take and substitute back into the original system to test. That's called verification. So then to check that, oh, this solution that I got, is it the real solution? And then the same when we do the other case, it will be the case for no solution. Now this thing depends. We can give you a question, say find the solution of the system if it exists, or we can completely start from other way around. We can give you the solution and you to test, is it a solution? If we give you a solution and we give you a system and say test it if this is a solution of this system, then we make life easier for you. That means you take the solution, you pop it into the system and then check if it's a solution, yes or no. That means you are doing the verification before even you solving the system. So you get the solution and then you verify it. So that's another way. Another way we'll be doing is we give you a system with variables, and then you the one who have to maneuver it and do the row operation or reduce row operation. We're going to see this notion later. Please don't be scared of the name when you hear row operation or reduce row operation. It's the one we're trying to introduce now. So once you use it and you reduce the matrix to some level where you can get zeros and you get 1 where you can easily work with the 0 and 1, we'll get to that stage also where you see that, okay, this is the case for no solution. That's the technique for reasoning. Infinitely many solution, that's the technique you need. For let's say exactly one solution, then you also they have that technique to use. So yes, those are all the things that we're going to see. But if you guys are asking the question before we even get to the notion, we want it there. Tapelo saying yes, go ahead. You are the one next. Yes, Tapelo? Can you please unmute? You are muted. Okay, we're going to ask Masabuko to talk. Hi, Masabuko, can you please unmute while Tapelo? Oh, Tapelo, you're fine. Can you please go ahead, ask your question?
Hello, sir.
Yes, we can hear you. Go ahead.
I wanted to ask, can every system be put into row echelon form? Because it seems like it's not possible.
Why do you mean it's not possible? Can every system be put into row echelon form? Why not? And why is it not possible? Why are you saying it's not possible?
I'm seeing the example you just did right now. You got
yes. Did you use elementary row operation here? Yes or no?
Yes.
Yes. So if you use elementary row operation to reduce the system, then you take the system, you reduce it in this way. Yes, there are some specific system where if you apply some specific row operation, you might be turning around. But for this case, yes, we have reduced the system. We have 0, 0 everywhere. So we only have the first row that we cannot make 0. That's the limit. We can't go further than this. Of course, we can use the colon, but it won't make a difference even if we use the colon. So the first one will be our pivot. Our pivot means is our reference, is the one we're going to use to answer the question. So the question is that now, instead of we using the pivot to answer, we're using the matrix, and then we're reducing this by using the elementary row operation to get the 0, 0. So instead of we answering with the pivot like we did here, you see what we did here is that we answered directly with the pivot. That's what we use. This is the pivot, the first row operation. So in this other option, what we're going to do is that we're not going to use the pivot, we use the opposite. We're answering the same question, but we're using the 0, 0 at the bottom to answer that question. I hope that is clear. So you see, I'm not going to make use anyway of that first row operation. I've already made use of it. Previously, I used the first row operation to say that, okay, the solution is infinitely many. What I did here is that I used the first row, I use the element inside so that I can create a 0, 0 at the bottom. Once I get the 0, 0, then I drop that pivot completely. So I'm going to answer differently. So that's the technique for gas, but we'll see it at a later stage. So usually, as you call it, elementary row operation, reduced row operation, we're going to introduce them at a later stage. It's going to be a row echelon matrix, reduced row echelon matrix, and then we get that. Yes, there are some instances where some matrices, someone give you a matrix directly like that. Yes, if a matrix is given to you, you can always find a way to find an operation to get a 0, 0. However, there are some matrices you cannot reduce them further than what they are. So here we got lucky, but we'll see there are some instances we come across too. So where you can't even cut it more than what you have, especially where there's a unique solution. You can only reduce it. After you reduce it, you reach a certain stage, it's enough to answer the question. That's all we're going to base our calculation on. Yes, Mazibuko, I think you're next. Please unmute to talk, or should we ask Tapelo to ask another question? Mazibuko, yes, go ahead. Yes,
Hi, sir, can you hear me?
Yes, I can hear you.
Okay, regarding the other lady's question, where she asked about where we have to show our
Calculation.
all this relations.
The operations and everything, yes.
Can we also describe them in words?
Yeah, but usually you see in the assignment, at the start of each assignment, if you see that I will post assignment 2 very soon. So I was just trying to keep you that once you do assignment 1, you should be able to have access to assignment 2 very soon. For those who did not do assignment 1, please make sure you go and do assignment 2 so you can have access to, you do assignment 1 so you can have entry access to assignment 2. You see, yes, normally as at the beginning of the assignment, I write show all calculations, or as somewhere next to a specific questions, also sometimes I say show all calculation. So it means that if you write some of this operation, let's say, you see, let's say from the matrix number, from this matrix here, the one you see on your screen, just the one below the one in blue, that augmented matrix. If from here you do not write this row operation, this guy's here on the right hand side, let's say you don't write anything here. Let's say there's nothing here at this stage. But then suddenly from this matrix, I see you, boom, you fall up here. How will I know that is you are the one who did this? How will I know which operation you have done to get there? You see, that's the challenge. I could be sitting next to someone else, a genius one who got the answer, and then I just copied it down. I could be someone else done it for me, and then because I don't know the operation, the person forgot to write the operation, I also copy pasted without writing the operation down. So yes, that's why I wrote -1 for notation. Each time you see in your place -1 for notation, do not come back to me, I beg. That means that you have done something wrong with the operation, and then I subtracted mark. So especially if I'm the one marking, yes. Each time there is a problem with the notation, or there is a passage from one place to the next, and I don't know how you get from first floor to second floor, or how you jump from third floor to first floor. If I see that there is no correlations about the basic concept, then I usually subtract the mark there. And even if I don't write -1 for notation, you will see that if the mark for this matrix here is 4 mark, I will give you 3. Don't come back and ask, because I will remark and give it even less. Yes, Mr. Paul Guy, thank you so much. I'm not sure if I will say, I say not great for me because there were so many questions, and then we couldn't continue a lot because we're basically we've gone beyond our time to cover some of the concept. But then nonetheless, let's just cover what from here first, so that at least next time we can move faster. Yes, guys, I hope you don't have any questions. Mazibuko, your hand is still up, and then Madansela, you're next again.
Yes, Madansela, then after you can please unmute to talk, then we'll give the chance to say what you wanted to ask earlier on.
Hello, sir, I hope you're well.
Yes.
I just wanted to say that next time, can you just focus on the lesson, and then people write down the question that they have, and then they ask them at the end. And then if they get confused at an operation or something, they can just unmute their mic and quickly ask, because that way we won't waste time. I don't know if you get me.
No, yes, you're correct. I completely agree with you. So that's why normally you see in the announcement, if I recall, I wrote that we're going to have a 45-minute discussion, and then the last 15 minutes will be for question and answers. But yeah, unfortunately, that's fine. I don't mind if we can intercept at each time, or just so that at least, because you know, this is an online discussion, and sometimes people get cut off with network issues, some social challenges, which we hardly know. So you see, you're going to struggle to know what you're struggling with, and then you might not also know how I'm struggling. I might know there are so many things that might take into consideration. That's why I don't mind asking them, but I would prefer, as you mentioned, so that we can have the 45-minute discussions fully, then we can have the last 15 minutes for questions. And then if the people can't answer their questions on time, then I completely also agree with you that they can also write them down in the chat. We can also tackle them in a fast and furious way. So that's also okay. So if everyone is happy with it, then yeah, next time we can stick to that. Yes, thank you so much, Madansela, for bringing that. Yes, I think yes, you can bring your questions since now we are answering the questions. Yes, go ahead.
Thank you. So this is a question from Unit 1.3 in the work through exercises.
Yes.
At the end, one of the questions was it gave a matrix X in the row 1, column 1 X, row 1, column 2 Y, and then I think Z and W. So 4 unknowns or variables. And then it gave another, and then it said that matrix equals another matrix. And this matrix in the first row, first column was X plus Y. And I can't remember the rest of the things now, and unfortunately I don't have my textbook on me. And then the question asked how many 2x2 matrices can you make that statement true?
Yes, but if you don't have the matrix, then you see we also struggle to have the matrix. At least if you have the matrix, then you can give us the complete information. But then if that is in unit 1. Is section 1.3, right? So we are getting there. Once we get there, we answer all of those ones.